Yeah, thanks a lot for having me in the webinar series. I'd like to give you a bit of an insight into how we in the computer science department looked at how we should teach in a world that's increasingly driven by AI, and also like in a world or like what we should teach for our world or for preparing our students for a world increasingly driven by AI. And most of the stuff was done in a series of workshops we had last year during the time when I was department head in the computer science department, to see like how do we need to structure our programs, our courses for AI. In principle, so artificial intelligence is pretty new, at least as far as commercial products are concerned, while the science behind it is already like decades ago, and in some cases, or in terms of some of the underlying principles and theories. The first commercial model was obviously ChatGPT, and that was just like 3 years ago. So, like, if you think about this, yeah, ChatGPT came right after COVID, so those were the two big transitions this decade. But until 3 years ago, all the stuff that we're doing now with AI was just unthinkable outside of academic circles. And then just 1.5 years ago, we had multimodal models. So models that understand images, sound, can produce images and sound, and thereby pretty much cover the whole range of content that we have these days. The adoption of generative AI has been explosive. I think that's the only word that we can apply to it, especially large language models, which are in principle just a very small part of artificial intelligence, but are the ones that are most popular and most commonly used. When people these days talk about AI or generative AI, typically we talk about large language models. There's a whole bunch of other research areas in artificial intelligence that I'm not going to cover right now, because I'm mostly looking at what are these commercially available models and how do they shape the world that our students live in and the world that we need to prepare our students for. And for the time being, that's mostly large language models. So that's what I'm going to focus in for the purpose of this course. The motivation is really like, where are we going to be 5 years from now? So in 2030, what do we need to teach our students to prepare them for that reality? And that starts with in 1 or 2 years. Like the students who are starting in 2 years are the ones graduating 5 years from now. And if you see how much has happened in the 3 years since ChatGPT came along, that's going to be quite interesting where we're going to be 5 years from now. Some of that, of course, has to be taken with a grain of salt. I mean, there is this hype cycle produced by or suggested by the Gartner consulting firm for any new technology, where we say, well, things always start like with this rapidly inflating expectations for any new technology. Then after this initial rapid rise of a technology and like the ascribing of all kinds of properties to it, comes a bit of disillusionment, where we feel that, well, they can't maybe do as much as we thought about. And large language models are kind of, according to Gartner last year, somewhere here on this downward slope, where if you see the discussions right now, is lots of like, oh, they can't do this, they can't do that. Will they ever be able to do this at all? And so typically we see a pattern where like a new technology will somewhere like plateau at some point where it will yield some productivity that's nowhere near the initially expected benefits, but has some solid contribution to productivity. So we'll see where all these new generative AI technologies and large language models, as you can see, are just one of them, where they will end up. A ton of it is in the pipeline, and we'll see which ones will survive and get to which kind of level on this cycle. There have been like lots of papers on like questioning how valid the output of large language models indeed is. So like, are they stochastic parrots? Are they just creating a bunch of hype? Are they creating bullshit in a relatively academically defined way? That might well be, but the fact is also, despite all the hallucinations and despite all the inaccuracies and the inherent biases that large language models have, they do produce output that's good enough for many use cases, good enough for many of our students to rely on, which makes a bit of that discussion a bit academic. So yes, it is not perfect, but it's apparently good enough to be used by students and good enough to not be immediately spottable by teachers, which makes it a problem. So we'll have to see how we deal with that, and that's the part of teaching in an AI-driven world. How do we live with the quality of AI output? Mm. The other thing that is like preparing students for an AI-driven world is, I think it's safe to say that generative AI is going to become even more ubiquitous and pervasive than smartphones. That looks like a steep proposition, but if you see that pretty much any tool that you open these days, whether it's your office tool, your email client, your PDF reader, even Excel, will start to have some agent telling you, do you want to do this with AI? Anytime I'm opening a Mentimeter presentation or something like that, even small, tiny services will start to have an AI agent in there, even these days. Whether that's always sensible is a different question, but students are bombarded by it. Not always, I believe, to their benefit, because I think we're encouraging them too much to delegate their thinking, which is not a good idea. But they're in this world where they're constantly being encouraged to use AI. So at the same time, a lot of the content that they are going to be consuming is going to be generated by AI, for better or worse. So the question is like, what does that mean for the way our students shape about and think about the world? How can they critically reflect on content? How can they create content? And content can be anything from an essay to a software program. If they've had no practice creating and critiquing good content from scratch using their own brains without an AI telling them how they should be thinking or what they should be creating and what it should look and sound. And so far, most of the teachers around the world have like created AI policies looking like this, like relying on academic conduct guidelines, relying on yeah, appealing to students' honor, giving suggestions for effective AI use. That's also what most university policies, including our AI policy in its current form, mostly do, is to give teachers relatively large latitude in how they want to use AI, what they want to allow, what they want to restrict, and how that works for their courses, which I think is a good idea, because courses are very different in terms of what they expect of students, what they want to prepare them for, if they're teaching theory, if they're teaching practical application, what kind of mode of teaching there is, if it's largely homework-based, if it's largely project-based. So it's very difficult to have like a one-size-fits-all strategy. And putting this into teachers' hands, I think, is the way to go, because they know what works pedagogically for their course and their course material. Having said that, this also shouldn't end up to be the way that students have to look at every single individual course and have a completely different AI policy on a course-by-course basis, which is why in the CS department we looked at, so how can we maybe align our policies a bit, and how can we especially align our strategies so that we're not just like looking at this from a policy perspective, what do we need to allow or forbid about AI usage, but what should we be teaching about AI usage? Because students are using AI at an increasing rate. Sometimes it's for inspiration, sometimes it's closer to cheating, with very fluid boundaries in between. And most of the time it's not for the purpose of cheating. So I believe our students are actually not lazy, but just like swamped with work. They might be embarrassed to ask in class or to ask on a class discussion forum, and it's less embarrassing to ask a chatbot where they can follow up. So that is quite understandable. And also there is the fact that Gen AI output is so good, like in the students' eyes. Why should I struggle to produce something inferior? I think that's the part that is dangerous, because if at the push of a button I can generate an essay that I feel as a student like I could never be able to write this well, sure, not when they start, but that's what they go to university for, to learn to write this well or to learn to code this well. However, if from the start they get output that makes their own work look inferior, we get into this vicious circle of like people not trusting themselves to do well, not trusting themselves or not allowing themselves to make mistakes, and therefore just relying on the AI rather than taking that leap of handing in something that they know is not perfect, getting feedback on it, and then improving. So that whole learning from mistakes part is cut out of the teaching equation. Teachers have the same problem. So we are struggling with identifying AI-generated work, and since we can't identify conclusively, we can't really sanction it effectively. Sometimes I feel like the only way is like if I say, well, this is too good, this can't be your work, but that's not a good thing to tell a student. Like, I don't believe this is yours because it's just too good. I mean, for one thing, there are that great students, and for another, it's not something that is really encouraging to tell students. So we can't really rely on tools to identify AI work. And even if I have a strong feeling, okay, that sounds like ChatGPT style, it's difficult to make that assessment that watertight that I would be able to sanction a student for. So that makes homework in particular tricky to deal with. At the same time, we're only beginning to think of the AI tool as a potential as a teaching tool. So where can we use AI to help us teach stuff without delegating too much of our own core competence to AI? I think that's important as teachers. Like, we have the pedagogical competence, we have the domain competence, and that's something we shouldn't be delegating too easily to AI, and thereby making ourselves redundant. I mean, there's a reason that we have people teaching people and not tools teaching people. At the same time, as teachers, we often inhibit some rather high inertia when it comes to adapting existing course materials. I mean, same, we are not lazy, we are swamped. And so, like, if that course worked last year, it's probably going to work again this year with minor modifications. So, like, the willingness to change a course radically in response to changes like this is sometimes not that strong. So that's why we wanted to see what could our strategy look like in the CS department, and we had a series of workshops in the last summer to look at 4 questions, like how do we assess students' work, if parts of it might be AI inspired or generated, how can we leverage tools to improve our own teaching, what skills and competences do our students need, how do we convey those skills, and on the program level, like what should a revised study program look like to reflect that vision. These are rather large questions, and we also knew that we wouldn't completely turn our program on its head because that has like all kinds of ripple effects on current students, future students, students from other departments, and so on. So we tried to find a way to gently mold our program into a way that's AI ready and AI aware without having the big bang renovation of the program. So university is very much like a big tanker in that regard. And what we came up with is that we found out that we have 3 types of courses essentially. So we have fundamental courses, which are just the basic skills and knowledge of the field that students should internalize without having to rely on any help. That means if they would need to rely on AI for this, they wouldn't be able to reason about any of the basic concepts. So really want them to be able to do this stuff on their own. Then we have computer science technology abstractions. So where we are talking about specific concepts that are implemented in certain technologies, and it's important to understand the underlying theory, to understand the underlying concepts, but it's okay to get help with transporting them into a concrete technology. So, for example, if I build if I build a web application, something that you can access through your web browser, like your Outlook or your calendar or your whatever news website also, then there are certain underlying technologies that are the same no matter, or underlying principles that are the same no matter which technology you're using to implement that application. And so we want students to understand the underlying concepts, but then use AI maybe to help them create technologies. But that requires like a nuanced view of what is possible to ask AI for, what can AI reasonably deliver, and how do we critically evaluate its output. And then we have courses that are extremely technology heavy. So these are courses where we're teaching particular technologies. And anytime when we're teaching particular technologies, for one thing, they're like foreseeable to come out of style anyway and being replaced with something more, with something new. And also, these are typically things that are easily generated by AI in the future. Currently, that potential might not be there yet, but it's something foreseeable where we could have a lot of technology-specific stuff being generated by AI if students understand these abstractions and the fundamentals. So these are courses where we feel we might be able to, in the long term, focus our teaching resources better on courses that are specifically focusing on AI tools for building software rather than teaching them to write this kind of technology software by hand. So against that background of these three course types, we said, so like, how do we want to classify our courses, both into how students use AI and how much AI content we have in the course? And so we said, well, there are courses where AI should be forbidden. We do want people to do this on their own. There should be AI that's allowed and supported, or there should be courses where AI usage is kind of like integral to what students are learning. So this goes back to these three types here, stuff that they need to know, stuff that AI is the whole point of the course, and things where there's like a nuanced way of dealing with AI for particular tasks, but not for the general understanding. So that's the horizontal axis here. On the vertical axis, we have the distinction of like if the content should be not AI related at all. So that's like basic computing concepts, basic algorithms, basic data types. These things are somewhere at the core of AI, but you don't need AI to teach them. Or are there concepts that are using AI to some degree? Or are we talking about making AI solutions, which is like, this is probably like the line that's most specific to computer science and not as translatable to other fields, because it's really using computing to make AI solutions. While these two here are probably also translatable to other fields, stuff that is AI, that has some AI affinity, and stuff that does not have AI affinity. And so given this matrix, we took all of our courses and we just put them out on a big table and started to cluster them and try to cluster them into these areas to see, okay, where do which of these courses fall into? That took a bit of shuffling things around, some discussion of like, okay, how much AI content should there be? How much support should there be? Should students know this by heart, or should they be able to get support by it? And then in the end, so if this is in a bit more readable form, that was what we came up with for like clustering the courses of our program into this matrix of how much usage should be allowed and how much content should be in that course. And I believe that could be a structure that might be applicable to classes in other fields and other faculties as well. So we had these quadrants where we had these fundamentals that don't involve AI, but we want to have our students mastering them without relying on AI, which means teachers should be motivated. Why don't we want students to use AI? Why do we discourage that? Why do we use presence-based assessment? Why do we really focus on students using their own brain for these courses? And that was the most of our fundamental courses going all the way through our first, second, and third semesters. Then we had courses that are about concepts that are directly AI related, but involving aspects where AI can be a valuable tool. So like in this case, creating stuff that's just like tedious to write in code, and then AI can help us generate stuff that's otherwise tedious to do, but still requires creativity on the student's part in order to develop the correct solutions. Here, teachers need to be able to give tasks to students in a way that makes them accessible to AI. So we're saying, for example, this is a task where you could use AI in the following forms. This is a task I would like you to do on your own. This is a way that AI can help you to do this. So here we're really looking at a critical, informed usage of AI for particular applications in these fields. Then we have two constructs, two sectors where there's nothing in there, where it just doesn't make sense. So like courses without AI contents can't have integral AI work. So here that doesn't make sense, this combination. Same here, if a course is about AI usage, we can't forbid users to practice it. So that means there's just no courses in here. But then we do have courses like here, which are concepts for which we have already some industry relevant AI support, and that students should start practicing to learn. So this is pretty much in computing, it's like where we look at industrial software development, where we can expect students to use AI in the future as well. And the degree to which they use AI here is just like going from the occasional support to really integral use of AI to build software. So that's what's going to be here in the second part, where the course should be designed such that students learn not just the technology, but specifically learn how to use AI in practice in their professional lives in the future, so that they have that skill just in the same way as we teach them how to use other software development tools like compilers, version control tools, debuggers, and so on. And finally, we have the last line here, like all the courses about like making AI systems. And even in there are some courses that we just want them to know and understand without having to rely on AI at all. So this is pretty much the theory behind AI. That's largely math. So we want them to be able to understand this without relying on AI. Then we have like building tools in certain application domains, and then the whole engineering of AI systems, so designing AI systems, the life cycle of AI systems, using big data for scientific computing, for example. All these courses have AI at their course, and so here we have assignments that integrally and heavily involve the use of such systems. So that's the overall matrix. This doesn't mean that we're now like turning some of these courses completely inside out, especially here on this side, where we might be renovating courses or replacing courses over time. That's something that will take quite a bit of time, as we may be phasing out some course material and phasing in new course material. But that these courses will probably change the most, or in some cases, courses that don't even exist yet. While over here, these courses will largely stay the same in terms of their content. We might just change them only in terms of delivery, for example, by having assessment that is largely on campus rather than at home, but without changing like what exactly we're teaching here. So the changes here mostly in terms of format, the changes here are much more in terms of content and format, which means these changes on this side can be implemented much sooner and much easier typically than the changes over here, which require constructing new course material and coming up with new ways of teaching these topics. So I've already said that student assessment is like a big part of dealing with AI. And of course, they try to maximize their outcome with minimum effort, which is valid when you want to be efficient, but maybe not conducive to learning. But given that they can rely on AI at home, that means homework is just not a reliable indicator of student competence anymore. No matter which way we try to package that, even if we have students who are supposed to like create an AI addendum where they explain how they used AI, that too can be generated. So like if someone really wants to use AI, there's pretty much no way for us to stop them, and probably also no way for us to reliably judge how much of their work is really their own. Which means for us, we came to the conclusion we should probably make most of the unsupervised homework voluntarily, so that the benefit for the students is not the grade, but the practice and the feedback that will be valuable for them to study for an exam that will then be supervised. And that should not just be the final exam, but maybe also midterm exams or so. Midterm exams might be useful, especially because that lack of pressure that comes with not grading homework, of course, might lose some students who just like slack off during the semester and then only finding out at the very end of the semester how much they have to catch up with, while having midterms kind of creates intermediate milestones for them to work towards. So that's something that we're increasingly, not as a firm policy, but like as something that more and more teachers are moving towards, to have multiple supervised assessments like midterms exams across the semester. And we're looking at if we should set some department-wide limit on like the amount of unsupervised assessment that we should have in a course, and maybe having like a minimum amount of supervised assessments to make sure that the grades that we're giving are indeed produced by what students do with their brains and not what they do in some AI agent. Of course, if you have more of these midterms, that means that students do need to be more on track with the course, need to be more in sync with the course. On the one hand, that helps them to notice when they're slipping. On the other hand, we might have here a bit more of a logistical overhead at actually handling those midterms. If we do them on Inspero, like a real final exam, that means hiring proctors, finding TAs to grade those, and so on. So that might be something that is also including some or involving some financial budgets that we might not currently have or might not have planned for. Maybe pooling some of these assessments could be an idea, but that of course also means pooling student stress as like lots of things are due on the same date, while they might prefer having things more spread out again. Then creates more logistical headaches for us. The other side is not just assessment, but also teaching. So we would like to encourage and train students to use AI effectively. And there we could use AI as well to explain a concept or generate a solution. And like from my students, I know they're already trying to do this. Of course, like there is like a slippery slope here, where like explaining something becomes solving something. But I think that's something that students and teachers need to figure out, like what kinds of useful prompts we can give them guidance on maybe, or how we can encourage students to use AI, for example, to create more examples or more artifacts that might be not the classic textbook style, which might be hard to digest for students. So it could be illustration of the concept, or if you work with Notebook LLM, turning like a chapter or like a lecture slide set into a podcast that might be a bit more easy to listen to. Not as a replacement for the actual course material, but as a way to make it more accessible in the first step before then really diving into the actual hard material. Letting AI generate examples, counter examples, all of these things are what AI is good for and what can be useful teaching tools. Of course, there might be some advantage for students who have a premium AI subscription, which could be ameliorated by having a subscription like that accessible through the university. So if the university would give anyone a subscription like a print quota or like a library subscription, that could help to put all the students on a level playing field there. All right. I'm running somewhat out of time, but just like one thing that I wanted to show you is a case study from my current course. I'm teaching now, which is the Computer Science 1 course this current semester, which has about 200 students, first semester students learning programming, sometimes for the very first time, sometimes recapping what they learned in mentor schooling. And the patterns I'm seeing there in terms of AI usage and how students learn, want to learn, and should be learning, in my opinion at least. So telling the students in that course, I want them to think. So I don't want them to sit like this. I don't want the course to look like that. But ideally, I want them to be in situations like this, where they're thinking, where they're creating, where they're learning, because that's, I believe, is at the core of this. Students are only learning by thinking. They're only thinking when they're doing something. They're not thinking and thereby learning when they're sitting in class. This is inspired by the thinking classrooms method from by Peter Liljedahl, which is I try to adapt a bit to computer science teaching. But it also means, of course, that in everything I do as I'm teaching this class, I'm trying to focus on the thinking part, on like getting students to think actively and not just sit there and not, and trying to make that happen is what I'm most concerned about in this class. And the idea, this is also like, these are all lecture slides I'm actually showing the students. The idea is here, how do we build skill? I mean, through practice, through understanding, through knowledge. Building all these things are part of skill. If we have only understanding, but not knowledge or practice, then maybe that's like the ivory tower. If we have only knowledge, but not practice and understanding, then we can play Trivial Pursuit. And if you only practice but no knowledge, understanding, then that's trial and error. But neither of these alone is getting us anywhere. So we need all of these three parts, deep knowledge, thorough understanding, and broad practice to excel in the field. How do we teach that though? Well, we do have textbooks, consultations, or Diamantina classes, so Viererlestre, and anything that's in this Silifon, that's like pretty much what is given to students. They get the textbooks, they can sit in a consultation, they can attend classes, but they're much more effective if they work actively, if they take quizzes on their own, if they build projects on their own, if they take notes on their own. That's really how they engage with the material and make it active in their mind. And even more boosters are if they're not just, so how do we understand stuff? By discovering something, not just by reading a book and saying, yeah, okay, got it, but by really discovering concepts on their own, ideally by building on top of knowledge that they've learned before. How do we get to knowledge? Or we make it even more effective by structuring it. So if we don't just like read the book, but then write our own cheat sheet on how do we structure this knowledge? How do we make it fit to what I already know? In which drawers in my head do I put it? How do I connect it with things? That makes the knowledge accessible and really much more alive. And lastly, practice, we mostly learn by making mistakes. So those are the things that help us to understand why things work, why things don't work, or why things work in surprising ways. All of that stuff happens with trying things out and often failing at them. Firstly, all of this involves active thinking. None of this involves letting someone do it for themselves. So that's why I'm telling them not to use AI in this class, ideally at all, because it will get in the way of all of these things. If AI is giving them solutions, they won't discover anything. If AI is giving them structures, they won't fit their own structure into their own head. If AI is like producing their projects for them, they won't be able to make mistakes. So none of this will happen. None of the thinking will happen, and thus none of the learning, or like much less of it, presumably. So I have then these typical slides of like academic conduct, that they need to do all this stuff on their own. They can use AI to understand concepts, but not to create solutions. And I'm trying to motivate that by saying, well, we're here to learn to think, not to delegate. And there's also actually research showing that if we delegate that learning to Gen AI, we won't learn it. We will be less capable to think later. And Gen AI is generally by design worse at reasoning than the students are. And like until 3 years ago, no one questioned this. Before ChatGPT came along, students thought, yes, we are here to learn and we have to learn. And just now it seems like sometimes people say, well, why bother? So this is kind of the argument I'm trying to give them. They will later not be hired for the ability to push buttons, but for the ability to think creatively, to understand clients' requirements, create solutions, and critically review existing solutions. And if they're relying on LLMs too much, they won't learn any of this. Same for like any reading, writing skills. In order to create stuff, you need to learn how to do this from scratch. So like whether this is writing an essay or coding something, if they're working with AI, then they're becoming an editor. They're not becoming an author. So they need to become an author before they can become an editor. If they right away become an editor of AI stuff, they won't have the background needed to judge either the AI stuff or the stuff that they need to judge in their business environment later. So I'm giving them ideas on how to use AI and what not to use AI for. Most of this is what teachers typically put on the slides. And all this stuff is first week kind of stuff, try to set the tone of the course. And then for my mid-semester evaluation, I try to see how much of that had any effect on the student. So I asked them for the mid-semester evaluation, where do you currently see yourself in the course? Or do you see yourself struggling or managing or falling behind or being ahead of the course? And so these were then in week 8, the 50 students who were still in class. As it happens, attendance declines. So there's some survivor bias in here, that the students who are still in class by week 8 are typically the ones who are more engaged. So probably they are doing better than maybe some of the students who disengaged from the class while still being active, submitting assignments, but not coming to class anymore. I mean, in principle, this looks good. Like most students still managing to keep up and only like a few struggling or feeling lost. So that looks encouraging. An interesting picture occurs when I asked them, so how do you use the different support avenues, like reading the textbook, attending classes, Dimer, using Gen AI, making notes, working on the course form with partners? And there was a difference for some of these, for like the students who said that they were managing, or the students who said they were struggling. I mean, textbook usage much higher among the ones who were managing, much less among those who were struggling. Same with like class attendance. Typically, so students being less engaged when they were struggling, except by using AI. So here we have like higher AI usage among the struggling students than among the students who were saying they manage. And also strikingly, and this was my biggest surprise, virtually no one using the course discussion forum. Even though I'm like touting that every week, students are just as reluctant to post on a public forum as they are to speak up in a public class. We need to be careful, of course, here, how much of this is correlation and how much of this is causation. I think there's more correlation in here than causation. So I'm not saying that when they're using AI, that's why they're struggling. I think it's more the case they're struggling, and so they're trying to use AI to help them along. But it might also be that, yeah, we need to see which of the tools we're giving students are really helping them to learn the stuff, and which of them don't really have much effect. Now, the interesting effect was the assignments in the class. So like every week they have to do a bunch of quizzes, a bunch of project assignments. These are graded. And so they typically earned around 80 to 90% every week. The midterm questions then were like quite a different story, where they like did significantly worse. And this looks the same if you just like see all the midterm grades here. So every dot is one student, and the associated exam grades, quiz grades. So you see students who have just skipped the midterm. It was optional, so it was not necessary, but had done differently well on the quizzes. We had students who skipped some of the quizzes, and probably that's why they did not so well on the quizzes, despite doing quite well on the midterms. We had students who probably did both the midterms and the quizzes, so they were kind of in line here. And then this is where I suspect ChatGPT is living, where students did significantly better on the quizzes than on the midterms. We have to keep in mind here that like these are the averages of about 160 tasks that they got over the first half of the semester. So like 20 questions every week, some multiple choice, some coding. So this is a pretty average. Here's the average of 160 problems. Well, this is the average of 7 problems, which means if they do this well on 160 problems, they should be doing this well on those 7 problems here as well. And if they don't, then that means this is probably not their own work. Which means students here rely on the quizzes or rely on AI much more for the quizzes than they do for the midterms, likely in this class. And when I asked them, like, why they use Gen AI this much or this little, again, broken down by the users who use it frequently or by the users who use it infrequently, the picture I got was like more encouraging than I initially thought. So like I thought, well, they're all just like cheating their way through the exam or through the quizzes. But most of the stuff that they mentioned looks very reasonable. So like producing examples for things I don't understand, making solutions better, helping me understand where I'm doing errors, getting into more depth in the textbook, having very specific questions that I don't want to ask in class and so on, translating things to Icelandic, finding simple errors, explaining why stuff is happening. So that all looks more like helping with the problem, not helping with the solution. But again, this might be survivor bias. So this is like those who attended class largely. Only very few of these were students who did not attend class. So maybe they are using AI for different purposes and to a more solution-oriented degree. Interestingly, the infrequent users mostly had, let's say, philosophical reasons for not using AI. So they said, I don't like it, I don't want to become dependent on it. So they didn't say it's not useful, but they made this deliberate choice not to use AI because they felt it would inhibit their learning, or it would not be correct, or I can't trust this. And so I think both of these groups have a point. These here could probably be a bit more critical. These here could use some of these uses of, or could, benefit from some of these uses of AI. But I think this is the part that makes it difficult to say, well, AI is just this evil thing for learning, or AI is this panacea for learning. The answer is probably somewhere in the middle between those two. And so, yeah, that's pretty much where I would like to stop after like going a bit over time with that dichotomy here and seeing what we make of that and what we could use for. Thanks a lot. And I'm happy to answer any questions or join the discussion.